So we're going to go ahead and continue to use our quadratic formula here. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is assuming that we have a formula in the following format. We're given an equation, ax squared plus bx plus c equals 0. It has to be equal to 0 or this does not work. Okay, so let's see what we can do. So first thing I do is find out what a, b, and c are. A is 3, b is 7, and c is 2. And so I have x equals negative b, which means the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. 2a. A is 3. X equals negative 7 plus or minus the square root of 7 squared is 49. 4 times 3 times 2 is 4 times 6, which is 24. All over 6. X equals negative 7 plus or minus radical 25 all over 6. Negative 7 plus or minus the square root of 25 is 5 over 6. So that's negative 7 plus 5 over 6 and negative 7 minus 5 over 6. So x equals negative 2 over 6 and negative 12 over 6, which means x equals 1/3 and negative 1/3 and negative 2. Okay, so this, by the way, the fact that this went and disappeared means that this could have been factored. The top of my diamond would be an x, the bottom one is 7, and that's 1 and 7. 1 and 6 to make 7 in the middle. So this is factorable. But I didn't factor it, I got an answer. Yay. Okay. So let's try again. ABC. A does not equal B. ABC. A is 2, B is negative 9, and C is negative 35. X equals negative opposite of B, which in this case is positive 9, plus or minus the square root of negative 9 squared minus 4 times A times C all over 2 times A. X equals 9 plus or minus the square root of 81 plus 280. And yes, I did use my calculator to figure that out. 4. X equals 9 plus or minus the square root of 361 over 4. The square root of 361 is 19. And so this is factorable. My numbers would have been negative 70 and 9, which apparently works out. I wouldn't have known that. That would have taken me a long time to factor. The quadratic formula doesn't take me long, but it might take you long. We've got 9 plus 19 over 4, and 9 minus 19 over 4, which means x equals 9 plus 19, 28 over 4, and negative 10 over 4, which is 7, and negative 5 over 2. but it still worked, and it worked relatively quickly. I like it better when this is not a perfect square. If it's factorable, I don't like doing this method. So why don't you go ahead and try the last two. I will come on with the answer for C in just a minute. We'll discuss it, and then we'll do the last one. All right, so I started with ABC. The only thing I did not do, I forgot to write x equals in front of this. And so plugged everything in, did some math, boom, answers. Now, this should take you some time. Make sure you're being very, very careful. I'll always evaluate that first and then evaluate that. Then I take, appropriate measures. Let's see if we can, so that's the answer to that one. Take a minute, look it over. Hopefully you got it right. If you didn't, you can try again. I'm going to go ahead and try D now. So go ahead, pause the video, try D. All right, so we have everything got plugged in. I ended up with 5 plus or minus square root of 25 minus 36 over 2. 25 take away 36 is negative 11. I cannot, right as of today, take the square root of negative numbers. So there's no real solution. And there's still no real solution, even once I learn how to take square roots of negatives, which is coming right up. There is nothing I can do. Okay? And that's where I am. Now, we did an introduction to this in the last video, but we never did finish that video. So I want to really quickly take a look at these methods. When should we factor? Well, when it's factorable. So I'm just going to write when equation is easy to factor. Okay, so I honestly would have factored all of these, except for maybe that one. That one I might not have noticed the factorization of. But the rest of them, I would have factored. Whenever the answers are nice and clean, it makes for good use with the quadratic formula when you're practicing and learning it. But the truth is the quadratic formula takes too long when it's factorable, if you know how to do it the other way. Although, of course, you can unsolve this and trick me. That's what a good friend of mine used to do. But this can only be used when it's factorable. Can only be used. So everything else I'm going to mention, these two methods, complete the square and the quadratic formula, will always, 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 always work. Factoring will not. Okay. All right, complete the square. I don't like to complete the square when b is odd. So I complete the square when a is an even number. Not when a is even. When b is even. And again, I'm talking about b in this format. B is the coefficient of x. So when b is an even number and a is equal to 1. So when there's no number in front and this is even, that's when I complete the square. And it used to not be true. I used to not ever complete the square if I ever. But now I know that is faster. That's when I complete the square. So this one, unless I'm teaching, would never have done this method. It's awful. Look how many of you got lost just in this part that's on the paper, not counting the fact that I had to grab another piece of paper to finish it, and it took forever. Okay? So I don't use that method unless I must. Okay? Quadratic formula, anytime you want. But particularly when I'm not going to use one of the other methods. This can only work sometimes. This one is not pleasant to do any other time. Officially, when a is there, by the way, we have to divide it out first. That is worse. So we don't like to do it. So quadratic formula work anytime I want. Always, always, always works. It looks intimidating. It's really not. I know it looks like it's hard to remember. It's also not. But the idea is that you just kind of, I mean, when I'm really doing this by myself, I square the number in the middle, times 4ac, subtract. I mean, I do a lot of it just really quickly. It takes me about a couple moves. So, love the quadratic formula. But basically, it's my backup to factoring. So, and honestly, now that I know how to complete the square really comfortably and confidently, it is my method that I will use when b is even, a is 1. Because it is faster than the quadratic formula then. And there's a weird thing that has to happen that I'll show you later. Okay, so that's that. And I will talk to you guys soon. Have a great day.